Today we'll talk about two types of numbers. We'll talk about rational and irrational. Rational and irrational numbers. Okay, we'll be identifying those types of numbers. Okay, don't write this, but just a quick review. Remember, before we used to have whole numbers, which are 0, 1, 2, 3, etc. Right? Not the numbers in between, which is 0, 1, 2, 3, the counting numbers. And then we talked about integers. Integers are whole numbers and their opposites. -1, -2, -3. So it's not just negative numbers, it's also positive, but whole numbers and their opposites. That's integers. Today we're talking about rational numbers, and rational numbers are all of these. They're integers, and they're numbers that are in between the integers. Decimals and fractions in between there. So what we're going to do is define rational and irrational, and it won't take very much room, but we'll write the definitions of each on both sides, and we'll put examples down. Rational, irrational. Okay, a rational number is basically when you can make a number into a fraction, when you make it into a fraction with an integer over an integer. An integer divided by an integer. If you can take a number and make it into a fraction with an integer over an integer, that's considered rational. The only thing is, though, you can't have this one right here. It cannot equal 0. Cannot equal 0. This bottom number. Then it would be undefined. Okay, let's give a couple of examples of that. Okay, like -2/3. Notice how we have an integer over an integer. Right? -2, that's an integer. 3, that's an integer. Therefore, this is a rational number. It's rational. How about the number 4? Is that rational? Yeah, because 4, that's the same thing as 4 over 1. See that? An integer divided by an integer. See? So that is rational. The number 4 is rational because I can make it to a integer over an integer fraction. Well, how about 2.7 over 3? Is that considered rational? Well, let's see. That's not an integer, but this one is. So it doesn't look like it's a rational number. However, if I multiply the top and the bottom by the same number, okay, if I do that, I'm going to end up with 2.7 times 10 is just 27. And 3 times 10 is 30. So this is really 27 over 30. It's the same thing. And therefore, that is an integer over an integer. So that works out. By the way, 27 over 30, 3 goes into both of those. So this is actually 9. 3 goes in there, 10. 3 goes into 27, 9 times. 3 goes in there, 10. So this is like 9/10. This is the same thing as 9/10. And in 9/10, that's the same thing as 0.9, right? Because isn't that 9/10? So there's another shortcut to this. If you see a decimal like 0.9, we know that a decimal that ends or a decimal that repeats is a rational number. So this is kind of like a shortcut. So instead of trying to make it into a fraction, like if you had 0.9, you'd make it a 9/10. Oh, that's a rational number. But you can just notice that if it's a decimal that ends or if a decimal that repeats, that is also a way to tell if a number is rational. So for example, a decimal that ends, well, 0.9. See that? It ends. It stops. It doesn't keep going on. That ends. A decimal that repeats might be something like 4.7 with a bar over it. See, that repeats itself. This is also considered rational. So if you can make it into a fraction with integer over an integer, or if it's a decimal that ends, or it's a decimal that repeats, this is known as rational. There's also some square root numbers that are rational. For example, square root 1, that's just, remember by definition, square root 1 is 1. And 1 is a rational number, because I can put 1 divided by 1. All right, another one, square root 4. How much is square root 4? That's 2. 2 is a rational number. It's also an integer. All integers are rational numbers. All right, another one would be square root 9, because that is 3. Another one, square root 16. That is 4. Okay, and you can think of other ones. For example, square root 25, that's 5. Square root 36, that's 6. Okay, all these are rational numbers, because if it's an integer, it's a rational number. So remember, rational numbers are integers and the numbers that are in between, the fraction and decimals that are in between. That's rational numbers. So now let's go to irrational numbers. Well, first of all, if you see a decimal that does not end, a decimal that does not end, and a decimal that does not repeat, a decimal that does not repeat, those are irrational numbers. So, for example, if I have a number like 2.8735521 4 ... keeps on going. Okay, is it repeating? No. Does it keep on going forever? Does it end? No, it does not end. Therefore, it does not end, it does not repeat, therefore it is irrational. Another one is pi. Pi is 3.14 ... It keeps on going. And it doesn't end and it doesn't repeat. That's called an irrational number. Now there's a lot of square root numbers that are irrational. So for example, square root 2, that is irrational. Square root 3. How about square root 4? No, that's rational. Square root 5. Okay, just to prove it to you, I'm going to press 2 and then the square root of 2. And look at that. It's 1.1414213. You know, it just keeps on going and going. It doesn't stop. And it does not repeat. It is irrational. So square root 2, that's irrational. Square root 3, same thing. 5, what would be another one? How about 6? 7? 8? How about 9? No, that one's all right. 10? That's irrational. 11? 12? Yada yada. You get the idea. Okay, so there's a lot more that are irrational than there are that are rational.